What's up, Pre-Calc Nation? Hopefully everybody's doing all right. This is day 5, 9.2, which is what we'll be working on. It's the second day of the 9.2. In the day 4 notes, we were introduced to the double angle and half angle formulas. And today, in this lesson, we are going to learn how to prove the following identities. We are all addicted to identities right now. We love them. But I'm going to do 2 examples here for you, and then you will do the day 5 problems. Okay, so let's focus on this first one here. All right, so we want to prove that the cosine of 3 theta is equal to this right side. All right, so let's go ahead and play with the cosine of 3 theta first. We know that the cosine of 3 theta we can write as cosine 2 theta plus theta. And we know that this is the addition formulas for cosine, which will be cos minus sine. So let's write that out. Cosine 2 theta cosine theta, and then it's minus sine 2 theta sine theta. All right, now we know what that is, and we know what that is. So here we know that the cosine of 2 theta by the double angle formula is cosine squared theta minus sine squared theta. And then I have the cosine theta next to it. We know that the sine of 2 theta, according to our double angle formulas, is 2 sine theta cosine theta. And then it's times the sine theta. Okay? Then what I want to do is go ahead and distribute the cosine theta and the sine theta. So when I distribute here, we're going to get cosine cubed theta minus sine squared theta cosine theta. Okay, so cosine cubed theta minus sine squared theta cosine theta. Minus, when I distribute the sine, you're going to get minus 2 sine squared theta cosine theta. Okay, now notice that these are like terms. Okay, so the cosine cubed theta is out front, and then it'll be minus 3 sine squared theta cosine theta. Okay? All right, now, it looks like I'm all simplified, but notice that we want to prove that the cosine 3 theta is equal to this stuff on the right. Do you see any signs here? No. So I have to get rid of the sine, but we know that sine squared theta, according to our old school identity, is 1 minus cosine squared. Okay, so let's move on. So now I can write cosine cubed theta minus 3 times 1 minus cosine squared theta. Cosine theta. Okay? Just a little bit more to go. Now distribute the 3. Cosine cubed theta minus 3 plus 3 cosine squared theta times cosine theta. And then distribute the cosine theta. Cosine cubed theta minus 3 cosine theta plus 3 cosine cubed theta. And then notice that cosine cubed theta and cosine cubed theta are like terms. So then finally I have 4 of those. 4 cosine cubed theta minus 3 cosine theta. Yes, we got it. All right, let's take a look at example 2. It looks like when I'm trying to prove this identity that I'm going to have to kind of play with both sides. So let's do the left side first. So first off, 2 cosecant 2 theta is the same thing as 2 times 1 over sine 2 theta. All right, and I know what sine 2 theta is. 2 divided by 2 sine theta cosine theta. And obviously the 2's cancel. So you get 1 over sine theta cosine theta. Okay, and we can write this as cosecant theta, secant theta. Okay, so the left side wasn't too bad. What I would suggest, and if we were in class together right now, I would have you do the right side. So everybody, the best thing to do is to pause this video and try to get the right side on your own. And then I will show you how to do it. So please do that now. All right, so now I'm going to do the right side. So cosecant squared theta is 1 over sine squared theta. All right, and then I'm going to write, and right here it's 1 over, so cotangent, okay, is cosine theta over sine theta. Clearly, this fraction over here is written kind of silly, so we just have to go ahead and simplify that to sine theta over cosine theta. All right, and since I'm multiplying, I get 1 over sine theta cosine theta. And I'm already happy because I know that that's what that is. But to finish it up, we can go ahead and write cosecant theta secant theta. Check. We got the 2 identities. Okay, once again, even when Ms. Freerichs and I are doing these problems, we could have these formulas in front of us. The half angle formula, the identities, okay, everything. Just have it in front of you because we want you to practice using the algebra with these trig functions. Thanks and have a great day.